Hello, I'm Julia Robinson Willmott, Principal Scientist with Normandeau Associates, and I'm manager of our wind wildlife team and our technology team. And I'm really happy to have this opportunity to talk a little about Normandeau's experience with aerial digital imagery. So thank you, EPRI, for organising the programme. Aerial digital imagery has been used in Europe since 2007. As pioneers of offshore wind energy development, several European countries started using aerial digital imagery for its safety and speed in collecting data. But it had not been used in the US, and there were no published comparisons between aerial digital surveys and traditional visual surveys. Normandeau was tasked with setting up a survey to compare visual surveys from low-flying aircraft, boat-based surveys, and high-altitude aerial digital surveys. And this we did off of North Carolina for BOEM. When we were analysing the data collected by the visual surveys, it was immediately apparent that all visual surveys have multiple layers of non-quantifiable influences around each data point, including the various abilities of recorders to ID species within their species groups, variability in ability to calculate distance or altitude for animals and birds, whether each individual was equally attentive or equally able to count aggregations of animals. And for boats especially, the alteration of species behaviour, with gulls and dolphins tending to be attracted to the boat, and animals such as turtles being repulsed by the vessel. And turtles were also repulsed from the low-flying aircraft, but to a lesser extent. So these were the primary conclusions from our BOEM study about aerial digital surveys. Species behaviour is unaffected by the survey platform. The X and Y locations are accurate, and there's no need to use distance sampling. The Z coordinate for birds, i.e. the flight height, can be calculated and QC'd, and an error associated with each one ascribed. You can cover a huge area rapidly with fewer uncertainties around the results, and consequently, you're less likely to double count species. And similarly, you can also take time counting large aggregations of species such as birds and mammals and fish that come in large aggregations. The greater accuracy facilitates increased confidence in change detection between surveys. So each step of the surveys, from data collection to IDs and analysis, can be consistent and repeatable and available for review. All data can be revisited. It's also safer flying higher than flying lower, and fewer people are needed on board. And aerial digital surveys significantly detect more turtles. In the North Carolina data for BOEM, there were 10 times more turtles detected from the digital aerial surveys than from the visual boat surveys, and 4 times more than aerial visual surveys. So Normandeau went ahead and reviewed potentially investing in technology, but as each of us knows from our mobile devices, camera technology moves forward incredibly rapidly. And so this was going to be a very costly investment. In the course of our study, we had reached out to all European providers and found APEM in the UK to have great imagery, frequently updated technology, and a similar business outlook as Normandeau. And from that moment to this, our 2 companies have jointly moved aerial digital technology forward in the US. The weakness of the technology is that it can only provide information during daylight hours. So nocturnal movements and migrations can't be monitored using this technology. For birds, this means that we can't contribute to the knowledge regarding roof red knot or piping plover, for example, which are 2 listed species that migrate over the Atlantic at night. To do that, we are in the process of developing alternative technologies, which we won't have time to touch on today. We're focusing totally on aerial digital surveys. Some of our most exciting studies have been to support sighting efforts and for recording baseline conditions in preparation for offshore wind development. 2 studies covering large areas have been conducted, firstly on behalf of NYSERDA and then on behalf of BOEM. Greg Lampman at NYSERDA tasked us with collecting information on birds, marine mammals, turtles, sharks and rays. And in the process of doing that, we discovered that we were also collecting information on some large bony fish shoals and attendant predators. And you can see the outlines of the survey areas on this slide, and all of the images on the slide were collected during those surveys. So imagery is collected from, at the moment, 1,360 feet or thereabouts, and the resolution is at 1.5 centimeters at the sea surface, which can be visualized by imagining the animal being made from 1.5 centimeter Lego bricks, where each Lego is a pixel. So the surveys for both Bowman and NYSERDA have also included the wind energy areas. For NYSERDA, this wind energy area is now Empire Wind and owned by Equinor. For BOEM, it's all the wind energy areas and call areas, of which only Kitty Hawk is currently under development by Avangrid. And for the wind energy areas for both NYSERDA and BOEM, we've been using a grid design which improves the statistical power to detect change post-construction. The same survey design can be used post-construction, although with the blade tip heights of the newer turbines, we'll probably need to fly higher in the future, which isn't a problem at all. One of the main reasons that flights aren't currently conducted from higher altitudes is because cloud base will need to be even higher. So weather windows for surveys and consequently opportunities for surveys become more constrained and restricted. Surveys using aerial digital imagery don't only center around the offshore, although right now the main market in the US is offshore. Our first joint venture was to survey the island of Kaula in Hawaii. Another benefit of using aircraft is that you can see areas at fine resolution that are otherwise very difficult to access. So, for example, with Kaula, it's being used by the military as a range to train aviators in air-to-surface and surface-to-air weapons delivery. So both live and inert ordnance have been used during training, and now there's unexploded ordnance remaining on the island, making any visual surveys quite dangerous. It's also the home of several thousands of seabirds, and it's these that the Department of Navy wanted us to monitor. And we started doing this in 2013 and have conducted 1 or 2 surveys a year ever since. The red, green, blue and near-infrared imagery has also been really great for monitoring vegetation changes. One such study is in the Everglades, where swampy conditions make access to some areas almost impossible. And we're seeing shifts in salt and freshwater tolerant species and watching the brackish zone vegetation as that shifts. And then there are the linear rights of way delineating habitats where some areas are either too remote to access or landowner boundaries prevent observers on the ground. And these, of course, all then get ground truth in easier to access areas. And then thermal imagery surveys that can track water leaks or effluent flows, and flying LiDAR surveys that can delineate shallow bathymetry. And then, of course, while you're up there, you can also add additional sensors on the plane, such as VHF radio tracking antennas. Obviously, all of these surveys generate a lot of data and supply a lot of imagery, which has to be stored, managed and analysed, QC'd, reported and visualised. And this we do on remote.normandeau.com. Normandeau developed this online data management system to be able to share progress and results easily with our clients. And frankly, it was for NYSERDA where the bulk of the interface developed. Each image has an accurate location. It's identified and QC'd, as in that top left image. There's a list of possible species. There's a way to describe your confidence at each identification step and say whether the animal is deeply submerged or near the surface, etc. That ID then goes automatically into the map with an icon, which can be clicked to see the image of the animal. For the birds, you get the flight height, and you can filter the map by birds at certain flight height bands, etc., which, if you wanted to know how many gannets were in the area flying at altitudes within the rotor-swept zone, you can do that on the map. Data can also be reported out in a tabular format, and using the BOEM sensitivity analysis information, you can map out hotspots for collision or displacement sensitive birds. And using a central data management system means that everything is fully traceable and the data set's kept clean and all the names for each species are kept the same. It allows for that consistency. So finally, a few insights into the future. The future of accessible high-resolution digital imagery from satellites is actually nearly here. If you're NOAA, you can already access some coarser imagery, and NOAA is currently working to train AI to detect and identify large megafauna such as manta rays and large sharks and whales, and they're using our BOEM and NYSERDA imagery to do this. And there's a few examples on this slide of those images. USGS and BOEM are also using our imagery to train AI to fully automate target extraction. By target extraction, we mean finding the animals in the image and framing it for ID. They're also trying some identification AI training to get beyond just the larger, easily identified animals and birds. And similar AI development is also going on with some other terrestrial uses of aerial digital imagery, where birds flying into a terrestrial wind farm, for example, are being identified to enable some curtailment if it's a bird, a species of concern. So I see all this happening very, very quickly and in the near future, and it'll be so great to be able to really see the globe at fine resolution and see all those animals in the ocean. So to wrap up, I'd just like to thank EPRI again for organising this, and to encourage you to check out Remote, and don't hesitate to contact me offline if you've got any questions or comments. Thanks very much.